So, hi everyone, and welcome to my talk. Imagine a world without passwords. It's easy if you try. But is it that easy? And would John Lennon actually have sung about it if he was alive today? So my name is Sigurhjörtur Snorrason. I'm a senior consultant at Knowit. And previously I've been working with making FIDO2 hardware devices. And I'll go a bit into detail what FIDO2 is and what FIDO2 hardware devices is a bit later in the talk. First of all, we're going to talk about passwords, why they're great and why we should not use them. What else than passwords we can use, and what options you actually have today to actually be passwordless. So, like I said, passwords are great. Everyone knows how to use one. Everyone has used one. And someone might even have used one yesterday on a bouncer and gone, hey, don't you know who I am? Which is a password that usually doesn't work. But they're also not very secure. They are symmetric. And by symmetric, I mean your password is your secret. So to prove to someone that you know your secret, you need to tell them your secret. And the issue with telling someone your secret, well, you told them your secret. And they know it. They're also easy to guess most of the time. Maybe you use your street name as your password or the name of your pet. Or you work at a company that makes you have really, really hard passwords with a lot of letters and a lot of numbers you don't even know that are numbers anymore. I'm going to talk about a short little thing that happened in February 2016 when Bangladesh Bank got robbed. The robbers there managed to steal almost $951 million, but in the end, they only stole $80 million. And $80 million is quite an amount, probably more than most bank robbers I've ever seen. It all started with a very, very simple spear phishing attack. They sent a couple of CVs, PDF, had some code in the PDF that got injected into the computers, and about 3 people opened these CVs. From those computers, they managed to do some keylogging, steal more access to other systems in that bank, and slowly they worked their way through the bank. In the end, they managed to get into the SWIFT system. Now, you can talk about the network security and the isolation and so on, but in the end, they used the passwords to actually get into the SWIFT system. And if you don't know what the SWIFT system is, it's basically where you do international transactions. They started triggering a lot of transactions, got them sent through, they came into the system, but due to a bit of bad luck, they didn't manage to steal more than $80 million. And the reason is they tried to use a bank in the Philippines, which was on Jupiter Street. A few weeks before that, the US had put a shipping company called Jupiter Shipping on a blacklist. This resulted in the transactions getting flagged because they had the word Jupiter in them and double-checked. So they didn't go through and they only got $80 million. But what can we learn from this? Well, Bangladesh Bank could have had the best passwords imaginable. They could have had the longest password, impossible to guess, impossible to do anything to actually just break them, because we can just steal them. We can keylog them, we can find them in other ways, and then we can just send them over and the system will accept it because it's your secret and you've sent me your secret. So we need something better. And a few companies in 2009 got together and tried to think of a way to do something different than passwords. They started by working with biometrics, basically, mostly fingerprints, to see if they could use that to log in. That had some issues as well because you're still just sending symmetric data. So a few more companies joined and they made something called the FIDO2 project. They tried to solve this with passwordless, basically. So they moved away from this biometric ID and went into asymmetric crypto. So for those of you who don't know what asymmetric crypto is or how it works, it's basically you tell someone something and they can use that something to prove that you know a secret without you ever telling them that actual secret. This is something you use already today. If you do SSH logins or things like HTTPS, is very much based on asymmetric crypto. The other cool thing that we added into this is that they use this secret then to make small little signatures on what your request is. So the thing that's using your login actually knows where it's coming from as well. It's not just, I'm coming from evil.com. The server will actually know you're coming from evil.com when it happens and can just go like, nope, I don't speak to evil.com. I only speak to friendly.com. This has then been a standard since 2019. So what can you do today? Well, In 2023, both Apple and Google released something called passkeys on your phones. This came with iOS 16 or Android 4.4. It's super easy to use. Basically, you go into a web page on your phone. It will show up and say, hey, do you want to make a passkey instead of a password for this site? You hit OK. It basically checks your identity in your phone and creates a passkey in the background. Super easy to use. If you're doing it on your computer, you might get a QR code instead that just goes, hey, do you want to use a passkey? Scan it with your phone, and the phone does the rest again. You can even cloud share this between your devices, so if you have an iPhone, you can also use the same passkey on your iPad as well. You also have something called virtual authenticators. These are mostly provided through your password managers. Your password manager might pop up, hey, do you want to actually make a passkey instead of a password for this page? Hit yes. It will store the private part of your passkey in the vault, in your password vault. So it's, again, very easy to use. You do cloud share it again with your password vault, which limits the security a tiny bit, because if someone hacks the cloud, they've stolen your secrets there as well. There are more secure options as well. You have platform authenticators. Windows Hello is one type of these. Basically, when Windows Hello asks you, do you want to make a login for this page, it will actually store it on your computer and lock it to the computer. And then you can just log in with your Face ID or your fingerprint scanner or even your PIN code on your computer, which is only local. It is locked to the machine, so if you want to use a different machine later on, you need to make a new key for that. And finally, you have hardware authenticators. There are multiple vendors. You probably know these as YubiKey most of all, but there are more. These are simple hardware devices you get, USB, NFC, or Bluetooth for that matter. Plug it into your phone or your computer. The key will be stored on the hardware device. So the result of this is that to actually steal your secret in this case, they need to steal your hardware device. They need to get actually something physical from you to steal your password. The biggest issue with this is these are very expensive, but these do offer you the most security possible for the modern world. So that was my short little talk. If there is any questions, I'm happy to answer them.